The next example in thermal stress analysis that we will take is, it is an example of a simple plate. First, let us go through the problem description. A plate of length L, width W and thickness T is fixed along the width on one edge and heat flow Q is applied on the same edge. So you can see over here, one edge is fixed and on the same edge there is a heat flow of 5 watts. The opposite edge is subjected to a temperature of 20 degrees Celsius. The ambient temperature is also 20 degrees Celsius. Ambient temperature in this case is nothing but the initial temperature. Find the maximum temperature, maximum heat flux, maximum deformation and the heat reaction at the given temperature. Okay. So now let us perform this analysis. Now in this case again I will do the same thing. We will add one steady state thermal analysis. Okay. The material that we are going to use is structural steel. So now let us directly go into the geometry option. Now if you look at the dimensions of the model, L is 0.2 meters. L is 0.2 meters, W is 0.05 meters and T is 0.005. So thickness as compared to the length is very small. So I can consider this problem to be a 2D problem. Okay. So let us come into the design modeler. I will come into the sketching area and I will draw one line. We will give the dimension. This is 0.2 meters. And we will give a constraint, a symmetry constraint between this point and this point. So now this is the line that we have. Now once the line is created, we will come back to modeling and we will extrude this sketch. And the extrusion is up to 0.05 meters. That is the width. So I will say this is 0.05 meters and we will generate the surface. So the surface has been generated. The thickness of this surface can be mentioned in the mechanical window. Okay. So I will directly exit from here. Next we will enter into the mechanical window. Now we need to mention the thickness. Can you see a question mark? That means some data is missing. So I click on surface body and we have to give the thickness. So I will change the unit system to meters and now I will say unit 0.005. 0.005 is the thickness. Okay. So now the thickness is also specified. Now let us mesh the model. We will use the default mesh settings. So the model has been meshed. Okay. Now let us start giving the boundary condition. So boundary conditions, they have mentioned that there is a heat flow of 5 watt and there is a temperature of 20 degrees Celsius. Now there is one more boundary condition, that is of a fixed support. Now fixed support cannot be applied in the steady state thermal analysis. Okay. So we need to apply a temperature on one edge which is 20 degrees Celsius and on the other edge there is a heat flow of 5 watts. Okay, so these are the thermal loads that can be applied in thermal analysis. After that you can analyze the temperature and heat flux. So we are interested into the maximum temperature and maximum heat flux. Also the heat reactions at the given temperature. So I can add a reaction probe at the temperature. And now we will solve the analysis. So the maximum temperature induced is 86.116 degrees Celsius. Total heat flux is 20,000, and the reaction is negative 5 volts. Okay, fine. So now we have understood the thermal results. Now close this and add a static structural analysis system to the solution. Enter into the setup. Okay. Now, according to the problem description, the edge where you are applying a heat flow, on the same edge we have to apply a fixed support. So, this is the edge where we have applied the heat flow. So, on the same edge I have to apply a fixed support. So, click on the static structural node over here and then add the fixed support to this edge. And now we have to calculate the maximum deformation. So I will add maximum deformation, total deformation over here. If you are interested, you can also add the stresses. And now we will solve the analysis. Now you can see that the total deformation is 7.7147 e raised to minus 5 meters. So if you check this into millimeters, the answer is 0.077147 millimeters. And the stress value is 173.78 megapascal. So because of the fixed support, maximum stresses are generated over here. Okay. So here we have understood that there are some boundary conditions which can only be applied in thermal analysis, and there are some boundary conditions that can only be applied in structural analysis. So it is a combination of both the analysis systems, right? So another example that we've seen for thermal stresses is a 2D problem, and we saw how to add boundary conditions from different analysis systems.